This last section is called integration by parts, but this is called a tabular method, and it's an integration that you can do, and it's a faster method than the other ones that we had, which was part one, which was the parts, you know, the v, dv, and du, and v, etc. And then we had the second method, which was the repeating part of it. So now this is the tabular method. So this only works if you have a polynomial right here, and something that will keep on repeating. That's when it works. Now, when you have an ln inside the function right here, it has to go by the first method that we did by parts. There's no other way to do this. You cannot use the tabular method. So the tabular method only works if you have basically a polynomial, and you'll see why when I do this, why you have to have a polynomial for this to work. So similar to the by parts that we've done before in part one, I have to select what's going to be basically my u, and then what's going to be my dv. So in this case, again, my polynomial will come before e. So I'm going to go ahead and set this up right here as kind of like my u right here is going to become 3x to the third. So that's 3x to the third. And then whatever is remaining, so that's this part right here, the integration of e to the 2x part right here, that's this part right here. Now this is called tabular method because literally it's like a table right here. And what we're going to do is, it's very linear thinking. So all of this part right here is going to be derivative. It's similar to when we set up the u and then the dv right here. It's kind of the same setup right here if you think about it. And then this right here was the derivative, and this is the integration, right? Well, then we had to do it again on the side, and we did part two, and pretty much we did the same setup. So to make it very organized, what you're going to do is all of this is going to be derivative, and then all of this is going to be integration, okay? So I'm going to go ahead and do the derivative side first, because that way it's going to help me decide how many of these integrations that I'm going to do. So you're going to go and do the derivative until basically you get to 0. That's when you know you're going to stop right here. So the first part then is going to become what? 9 e to the second power, right? Because 3 times 3 is 9, okay? And then we do it again, the derivative. So 9 times 2 is 18. X to the first, right? Because we just subtract 1 on the exponent. And then this is like a 1 right there. So 1 times 18 gives us just 18. And then derivative 18 is 0 right there. So that's when I know I'm going to stop right there, because it needs to get to 0 at the end. So if it gets to 0, then I know I'm going to stop right there. So which is going to help then on the integration part of it, because then I need to match it up until I get to this part right here. So I just take the integration until I finally get to that part. So in this case right here, again, we need probably a little u sub right there, because that exponent right there is 2x. So I have is then u to the 2x right there. So then du is equal to 2 dx, right? And then I have is a half right there. Du is equal to dx. So let me rewrite this again. So I really have is then 1/2 the integration of eu du, right? Because that makes it easy for us. Okay, so the integration, we love eu because then it repeats itself again, right? So the first part then is I'm going to go ahead and take that integration. That's the 1/2 eu, right? Which is then 2x. So I'm just going to go ahead and put the 2x in there. And so then that's it right there. Okay, so now the next part is I'm going to take the integration technically of this again right here, but what you're going to find is it's going to be the integration of eu again, which then gives us the half again. So the trick is, because this coefficient of half, all you have to do is basically, because it's going to repeat itself right there, is just keep on multiplying by 1/2 to each one until you get to this last part right here that it matches. So then 1/2 times 1/2 gives us what? 1/4, right? E to the 2x right there. And then again, 1/4 times the 1/2 again gives us 1/8. So that's 1/8 e to the 2x. And then again, 1/8 times 1/2 gives us 1/16. So 1/16 e to the 2x right there. Okay? All right, so then I'm going to go ahead and do this diagonal thing. So it has to be matching up diagonally. So diagonal, diagonal, and diagonal. So it matches up. And then we always start with positive. So think of it as you have to always have a positive thought first. So it's positive, negative, and negative. Okay, so we're not doing by parts on the side and keep on repeating by parts. It's actually that parts of it turns into this tabular part, is very organized and tight right there. So now we just need to put it together. Same thing as what we did when we did by parts. You cross multiply kind of idea, same idea right there. So I have is then 3 times 1/2. So that's going to give us what, 1/3? I'm sorry, 3 over 2. So 3 over 2 x to the 3rd power e to the 2x right there. And then I multiply across for this part right here, but there's a negative involved right there, so that's a minus, and then that's 9 over 4, right? So minus 9 over 4 x squared, right? And then e to the 2x. Then I multiply across for this part right there. It's a plus though, so 18 over 8. I think if we can reduce that, right? So we reduce it to what, 9 over 4 x e to the 2x, and then I multiply again for this part right here, and this is a negative right there, so that's going to be 18 over 16 is going to be what, 9 over 8, so that's minus 9 over 8 e to the 2x right there, okay? And I'm actually done with this problem, so I'm going to go ahead and put plus c right there. So if you again look at this right here, we basically did by parts, but we put it in a very organized format right here. And so just cross multiply for each one of those guys right there. That's what this is right here. If you look at it, it should give us in order the polynomial. So if this is x to the 3rd, it should, you know, go down and x to the 3rd, x to the 2nd, x to the 1st, and then there's what is that, constant basically, right? And then the plus c right there. Okay, so that's it. This is the integration by parts for this problem right here. Normally we would have to do by parts on the side. If you think about it, that's 1, 2, 3, probably what, 4 little by parts on the side right there, and it gets a little messy right there. So instead of doing that, we're going to make it organized and put in a tabular format right here. But again, this only works when you have a polynomial right here. It has to go to equal to 0 right there, because that's when you know you stop. And it cannot have an ln x. As long as you have a polynomial with no ln x, then this works right here. Okay, let's try another example. So this one, same thing. This is a polynomial. This right there is a polynomial, and this is a trig function right there. So I'm going to start with my u as polynomial as x squared plus 2x. And then the integration, whatever is left over, the dv part of it, right? So what's left over is the sine x right there. Sine x dx, okay? So again, everything right here is derivative. Do that first, so that way when you get to that 0, you know when you're going to stop, so that way the integration will match up to this. So the derivative of this is what, 2x plus 2, right? And then I take the derivative again, becomes 2, because that's the only one that needs a derivative. The derivative of this becomes 0 right there, so I know I'm stopping right there. So I just have to match up on my integration. And then sine, remember, sine is up here, so we're going up on integration right there. So since sine is here, the integration of sine will be the negative cosine, so that's negative cosine x. And then come down this way will be negative sine x. This is when it really comes in handy, this little chart right there, right? And then come back up here is going to give us positive cosine x. Okay, so we cross multiply, cross multiply, cross multiply. We do positive, negative, positive, and then we just put it together and we're done with this problem. So then I have as a negative, right, because of that right there, so a negative, and you probably want to distribute that. X squared plus 2x right there times cosine x, and then this is going to be negative times negative is positive, so that's plus, and then it's 2x plus 2 times sine x, right? And then this right here is going to be positive, so that's a plus 2 cosine x, so 2 cosine x. And since we're done with it, we just need a plus c right there. Now, you could distribute this negative to this next part right here, but I would actually just keep it outside, keep it nice and tight, because that way I can see that this right here, the polynomial, this is to the 2nd power, this is to the 1st, right? And this is a constant, so then it just goes in order. Sometimes actually this is good. So just keep it like that, okay? So that's it for the tabular method. All right, go ahead and try the classwork for this now.